Guys, welcome to Code Champa. Today we'll be solving an interesting problem. Valid parenthesis in an expression. This question has been asked in many interviews, especially if you are appearing for on screening round. You might expect this question. Okay, this is a very simple question if you have basic idea of stack. So you will be given an expression, basically a string, okay, and you have to find that the braces are in the correct order or not. Let's say if let me give you a simple example. Let's say if this is the question, okay, this is the string basically. This one is having one opening bracket and the similar counterpart. Basically, we have the closing bracket. So this is balanced. Okay, let me go to the second string basically. Let's say this one. You can see we have two opening brackets. We have only one closing bracket, and this closing bracket, basically this one is matching with this one, not with this one. So this is not at all a balanced expression, basically valid parenthesis. Okay, let me have some more examples. Let's say if I go through this example basically. Okay, this has two opening brackets and two closing brackets basically, but the orders are not incorrect. Basically, if you'll see, this bracket, this opening bracket and this closing bracket is different. Okay, and hence basically it's not a valid parenthesis. Okay, so how we are going to solve these questions? Okay, so we will be using stack. Okay, now what we will be doing, let me take an example, the first example basically, which is our the string. Okay, okay, this is basically the string. We'll be having a stack. Okay, what we will be doing is we'll be iterating over this string at every index basically, and once, like whenever we are getting any open bracket basically, we'll be pushing it into stack. So let me go through this. Let's say I value will be pointing to index of that string. Okay, so basically when my I value is 0, basically it is pointing to this index. We have an opening bracket. Okay, so what we'll be doing is we'll be pushing it into stack. Okay, when we are updating, again there is an opening bracket, so we'll be pushing it into stack. Now when we are in text 2, this is a closing bracket. Okay, so what we'll be doing is we will be popping element from the stack. Okay, so not basically not popping, we'll be checking the peak element, which is basically this one. Okay, if this is the correct bracket, this is the correct opening bracket for this index, then what we will do is we will pop this bracket. Okay, pop. But if it is not matching, I mean if it's not the matched pair, then we are just going to return the we are just going to return false. Okay, so in our case, this is a valid closing bracket of this opening bracket, so we are going to pop this element. Okay, now when I'm at index 3, this is also my closing bracket. Okay, what's the peak element then? This is my peak element basically. Yes, it's the matching pair of this closing bracket. Then what I'm going to do is I'm going to pop this element. Okay, now what I'm going to do is I'll be iterating at index 4. This is an opening bracket, I'll push it into the stack. Okay, now when when the index is when we are at index 5, this is a closing bracket, and yes, the matching pair is the peak element is a matching pair of this closing bracket, so I'm going to pop this element. Let's go to index 6. Okay, This is an opening bracket. I'll push it into the stack. Similarly, when I'm at index 7, which is this one, this is an opening bracket. I'll push it into the stack. Similarly, 8 is an opening bracket. I'll push it into the stack. Okay, let's go to 9. 9 is a closing bracket, and the peak element, basically this one, is a matching pair. So I'm going to pop this from the stack. Okay, let's jump to this next 10. This is an opening bracket. I'm going to again push it into the stack. Let's go to index 11. This is the closing bracket. Okay, so what I'm going to do is I am going to see the peak element. Yes, the peak element is a matching pair. So I am going to pop this element out. Okay, let's go to index 12. Yes, the peak element is a matching pair of this closing bracket. Okay, let's pop this element. Okay, again, when we are at index 13, this is an opening bracket. I'm going to push it into the stack. When we are at index 14, this is a closing bracket and the peak element is a matching pair. So what I'm going to do is I am going to pop this element out. Okay, let's go at index 15. Okay, 15 is this element, this basically bracket. What I am going to do is I'm going to check the what's the element remaining in this stack. This is the remaining element. Okay, this is a peak element basically. So this is a valid braces basically of this closing bracket basically. So I am going to pop this element out. Okay, now since we have since there's the length is 16 and there is no element at index 16, obviously we will be coming out of the loop. And if our stack is empty, that means there is no opening or closing bracket left in the stack. It means it's a valid parenthesis. Basically, the expression is balanced. If the stack is not empty, it simply means that the entire expression is not valid. Okay, so this is the logic behind this is the approach for solving this question. Okay, what will be our time complexity? Okay, so if you will see, first jump to the question first. Jump to the part of writing code, and then I'll explain you the time complexity and space complexity needed in the um, co entire code basically. Okay, let's go to the question first. Let's go jump to the code first. Okay, so I'm just writing the function. Okay, let's uh, since it will be returning boolean. Okay, boolean check, sorry, check balanced. I'm just writing balanced. Okay, what will be accepting? Will be accepting string. Okay, yes. Okay, fine. So first what I'm going to do is I'm writing this code in Java. You can use any of your language. I'm getting the length, which will be, I'm writing str. Okay, str dot length. Okay, fine. I'll be using a stack since I told you so, and stack will be pushing the character. Stack will be storing the character basically. So I initialized this. St is basically my stack. Okay, sorry. Okay, fine. So what I'm going to do is I'll be running one loop. Okay, till length L. Okay, I plus. That's it. So what my condition was, if it's an opening bracket. Okay, opening. So I am going to push it into this stack if it's an opening bracket. So let's say if str dot caret equal at index I equals to opening bracket, basically this bracket, or let's say if it's like this, if it's this bracket, or so what I'm going to do is I am going to push it into stack. What I'll be pushing that character at that index. Okay, fine. What if that, what if it's a closing bracket? So I'll be checking if I'll be checking if my stack is not empty. Okay, stack is not empty. This needs to be checked because I am going to find the peak element and I'll be popping it. So I need to make sure if that stack is not empty. Okay, okay, stack is not empty, and the peak element basically, which is st dot peak, let's say peak element, if it is this bracket and str dot caret basically is str at that index is basically the matching pair. This should be the bracket. Okay, and okay, this is one of the condition basically, or we will check for p. If this is the bracket, then we should have, then okay, this is one of the another condition, and one more. Okay, fine. So if it satisfies this condition, it simply means if I mean stack is not empty, and if the basically the bracket at that index is a closing bracket, then the peak element should be this. If it's a closing bracket, if this is the closing bracket, if this is the closing bracket, then the peak should be this. If this is the closing bracket, the peak should be this. If none of the, if any of the conditions, I mean if like none of the conditions satisfy, then simply means it's not a valid parenthesis. So basically if this condition satisfies, what I'm going to do is I'm going to pop the element from the stack. Okay, okay, else basically else simply means that they, it simply means that like what happens if the stack is empty, it means the expression starts with, expression is basically having a closing bracket without having an opening bracket. So it simply means it's not a valid parenthesis. Okay, another condition is if the peak element is not matching with the current closing bracket. It simply means the parenthesis is not balanced. So what I'm going to do is I'm going to return false. Okay, what if like what if I went through like none of this like I never encountered a false in the entire loop. So what I'm going to do is, okay, this, just give me a moment. Okay, I have closed. Okay, so this is the closing of for loop. Now what I'm going to do is, like, this is very important. If my stack is empty, then it simply means I have I have the matching pairs. I have already got, like, the entire expression is balanced. Okay, the number of closing bracket is equals to number of opening bracket, and each opening bracket has the correct pair at the correct index basically. Okay, so I am going to return true. Okay, if it is not, then simply means this entire expression is not balanced. Okay, so this is the complete code. Okay, let's jump to the time complexity. Okay, so here if you'll see, we are running a loop till the string length basically. Okay, so if the string contains n character, so the complexity will be order of n. Okay, what will be our space complexity? Right, you can see we are using stack. Okay, stack, let's say if the entire expression is having having an open bracket, so in that case what will be our time complexity? What will be our space complexity? We will be having stack size of length n. Okay, so in the worst case, when the entire expression is having n, entire expression is having opening bracket, then we are going to push every element into the stack, and this condition basically, if and else, will come in the end actually. So the entire expression, so the space complexity will become order of n.